Hey, what's up? This is Chris Plush from CG Masters, and in this tutorial, we're going to build a shader to enhance an ice texture by giving it a parallax type effect. In other words, we're going to make a flat plane look like ice that has depth underneath the surface. What we're going to do is create two layers of the texture to create the depth, and then we'll add a vertical stretching to the bottom layer to give it volume. And this is compatible with both Cycles and Eevee, though it's definitely a little bit better in Cycles. And this shader was originally made by Arendelle Woodford, and I modified it for this tutorial. Arendelle made the other shaders for my course Master Procedural Texturing in Blender, and you can find out more about that course in the description. And that course is for any skill level, but I'd say this parallax tutorial is a bit more on the advanced side. So for this, first let's set up our basic ice shader by using some image textures. So make sure you downloaded the resource files for this tutorial under the video. The starting blend file already has the images packed into it to make this easier, so let's open that up. Open up Parallax Start. And in this file we just have a basic plane, and this has the basic default material you can see in the shader editor. And before we move on, make sure to enable Node Wrangler in the preferences. So if you go to Preferences and Add-ons, type in Node in the search field and make sure Node Wrangler is enabled here. This is going to give us some extra hotkeys that make working in the shader editor much faster. Alright, now let's work on adding in those image textures. So let me click on this and stretch it over there a little bit so we have some more room. And I'll zoom out and pan to the right here. We're going to add a few image nodes here. So let's press Shift and A for the Add menu. And from the Texture menu, add an image texture, and we'll drop it here. Now, for this basic material, there will be a color map, normal map, and roughness map. So with this node selected, let's press Shift and D to duplicate it, and I'll move it straight down to there, and then press Shift and R to repeat that last action, so we now have 3 nodes. And now for the top image node here, let's click on the drop down here for the image library, and I already have some image textures packed into the blend file, so for the top node, we'll load in the color map, and for the second node, we'll load in the roughness map. And for the third node, we'll load in the normal map. And since the roughness map and normal map both have more than just simple color data, we need to make sure to change the color space from sRGB down to non-color in order for their data to be interpreted right. So change it to non-color for roughness and for the normal map. And now let's preview these textures real quick. And to do that, over in the 3D view, let's press the Z key and switch over to Material Preview. And now if I hold Control and Shift and I left click on each of these to preview them, you can see we have our color map, our roughness map, and our normal map. And now let's connect all of these to our principled node over here. So let me hold Control, Shift, and left click on the principled node to plug that back in. And for the color map, I'll connect the color output to the base color input of the principled node. And for the roughness map, connect the color to the roughness input. And for the normal map, we're going to have to run that through a normal map node first before we can connect it. So let's press Shift and A, and from the vector menu, add a normal map node. And we'll drop it right in the middle there. And now let's connect the color from the normal map to the color of the normal map node. And now we can use this as the normal map by plugging it into the normal input of the principled node. And let's zoom in and let's see what we've got so far. So that's looking pretty good. I think the normal map could be a little bit stronger. So let me crank up the strength here to 1.5. And that should do for now. And this is looking pretty cool as is because the image texture nodes are good to begin with. But once we add that parallax effect, this is going to look really awesome. So our next step is to connect texture coordinates to each of our image texture nodes so we can scale them all. So let's go to our top node here and click on the vector input and drag that off and just drop it in empty space. And then a search field pops up where we can select a node to connect to it. So type in geometry and then select geometry position. And that'll connect to the position coordinates as the texture coordinates for this image node. And let's connect position to the other image nodes as well. So there's a number of different texture coordinates you can use for images, including the options in the texture coordinates node, obviously. Position is going to give us the location of each point on the surface, and that's what's used for positioning the texture. This will be more ideal in this situation since we're trying to create an effect that's based on exactly how we're viewing each point on the surface. There might be other sets of coordinates that would work fine for this too, but position will definitely work. Now, in order to scale all these image textures together, we'll need to scale the texture coordinates running into them. And since the position coordinates are vector information, we'll need to use a vector math node to scale them. And we'll need to alter those texture coordinates before they split off and go to each of these nodes. So it'll be easier if we just had a single line coming out from position, and then that way we can add the vector math node along that line, and then it'll split off and go to the 3 other nodes. So to combine these 3 lines into one, we'll hold the Shift key, and then right-click and drag through all 3 of them, and that'll combine those 3 into one reroute node. And now let's separate these a little bit so we have some room here for a vector math node. And now let's press Shift and A, and from the converter menu, add a vector math node and drop it along that line there. And now let's switch this vector math type to scale, which basically multiplies the entire vector. And when it's set to 1, it's multiplying by 1, so everything looks the same. But now we can increase this or decrease it to make the texture size larger or smaller. So that's awesome. But I'm going to keep that set to 1 for now because I think that looks like a fine amount of ice for this amount of surface. Alright, now here's the plan for the parallax effect. We'll be creating multiple layers of these image textures, and by adjusting each layer's texture coordinates, we can have them display a certain way that makes one layer look lower than the other depending on the view we're in. And we'll also add a dithering effect that'll help stretch the bottom layer out vertically to make the depth effect more convincing. Now, since each layer will basically need its own texture coordinates so we can make them display differently, we can't just simply reuse these image nodes since you can only have one set of texture coordinates running into them. But what we can do is group all of these nodes together so that we can reuse them to create the other layers. So let me left click and drag over all of these nodes right here, not including the geometry node and not including the principled node. And that'll select all of them. And then let's press Ctrl and G to put them all in a group node. And as soon as you do that, Blender takes you inside the group node. So let's press Tab to get out of it. And there's our group right here. Let me stretch that out a little bit. And let's click on this field and rename this to Image Textures. And you can see this group has just one input right now, and this is for the texture coordinates. So if I wanted to reuse this node but plug in different texture coordinates, what I would do is simply duplicate it and then run different texture coordinates into the duplicate group. But we'll be doing that later on. Right now, the next step will be to just rename this vector right here to something like texture coordinates, just to better clarify what it's for. So let me select this group node. I'll press Tab to go into edit mode of it, and then press the N key to open up the right side toolbar. Then go over to the Group tab here for the input and output options. And here's our vector input up here. So let me double click on this to rename it, and I'll rename it to Tex Coords. And while we're here, we can change the output names too if we want to. Let's see how they look. So we have the color map connected to color. The roughness map is also connected to something called color. So let's rename the second color output here to roughness. And the third one's for the normal map, and that just says normal, and that's fine. All right, so let me press the N key now to get rid of the right side toolbar. And while we're inside the group node here, let's set up an input for this scale value right here so that we can control this scale property from outside of the group. And we can do that by simply connecting an empty socket from the group input node right here to whatever value we want to control outside of the group. So I'll connect this to the scale value. And while we're at it, I also want to be able to control the strength for the normal map outside of the group. So let me click on the next empty socket and drag that to the strength value of the normal map node. All right, and let's rename these for a little more clarity. So let me press the N key for the right side toolbar again. And let's change the scale value input here to say text scale. And let's rename strength to normal strength. All right, and then let's press Tab to get out of edit mode. And there we go. We now have these two new inputs here that we can use to change things within the group. And let's set up some value nodes and connect them to these inputs now so we can control these values from the sidelines. So let me press Shift and A, and from the input menu, add a value node, and I'll press F2 and rename this to text scale, and connect this to text scale here. And I'll change the value to 1. And then let me duplicate this and move it down, and I'll press F2 and rename this to normal strength. And let's connect this value to the normal strength there, and we'll crank this up to 1.5, which is what that value was. All right, let me select those, and I'll move them under there, and there we go. So now our basic texture is set up, and now we can start working on the other layers of it. Now the next step is to create another layer of this texture, and through some node magic, we'll make it look like that layer is lower than our top layer here. For example, if I were to duplicate this plane and move it up a little bit, this is the depth effect we're looking for. For example, when I pan to the right or to the left, you can see the lower plane is moving a little bit differently because of the three-dimensional perspective involved. Like for example, on the left edge here, we can see the lower plane. But as I pan to the left, it's almost like the lower plane moves to the right and goes underneath the top plane because it's moving slower than the top plane. And this is just basic perspective. It's what gives reality depth. And this is what we're going to try to achieve with just nodes and just a single plane. All right, now to start off creating this other layer, let's select our image textures group node here, and I'll press Shift and D to duplicate it and move it all the way down here so we have some space to work with. And for right now, let's plug in all three of these nodes into this. So let's plug the position texture coordinates into the text coords input here, and texture scale into texture scale, and normal strength into normal strength. So now this group node will look exactly like this one. And let's preview it by holding Control, Shift, and left clicking on it. So this layer is set up just like our top layer here. But depending on the view that we're in, we need to make this layer look lower. And that's the important part. It has to be based on the view we're in to be a convincing effect. The depth has to look three-dimensional. So we need to alter the position coordinates using the view that we're in. And we can do that with an option in the geometry node called incoming. And if I hold Control, Shift, and I left click on this a couple of times until we're previewing the incoming output, and then I rotate the view, you can see that there is indeed some kind of view-based effect happening with this option. Now, the next steps are a little bit tricky to explain in a concise way, but I'll give it a shot. So the incoming value tells us the direction of any point on the surface to the point of view, or to the camera viewing it. For example, if I press numpad 7 for top orthographic view, you'll see the entire plane is blue, and blue represents the positive Z direction in Blender. So when we're in top view, the camera is directly above the entire surface. So if you were to draw a line from any point on the surface to the camera, that line would be traveling in the positive Z direction. So that point on the surface is then colored blue to represent that. So all of these colors basically just represent the directions we're viewing every point on the surface at. And that's the information we get from the incoming value. Knowing what angle we're viewing each point on the surface from is essential for this parallax effect too, because if we want to fake a three-dimensional depth effect from every view, we have to alter the original texture coordinates based on that view. So our next step is to mix our incoming values with our position coordinates to alter the position coordinates based on the view. And since both position coordinates and incoming values are both vector information, we'll need a vector math node to mix them together. So let me zoom out, and first let's hold Control, Shift, and left click on the image texture node down there to preview it again. And we'll put a vector math node along this line right here for the position coordinates. So let me press Shift and A, and from the converter menu, add a vector math node and drop it on that line there so it connects. And let me pull this down here. And let me drag all these to the left as well, because the lines are starting to get tangled up a bit, and that should be fine for now. All right, and now let's connect the incoming values to the add node here so it adds them to the position coordinates. And let's check out the results. So we're definitely getting somewhere. You can see there's definitely a view-based effect going on with this layer now, although it clearly doesn't look quite right. For example, when I pan to the right, you can see the texture moves even faster to the right. And the same thing happens when I pan to the left. That's not quite the effect we're looking for. Do you remember the example I showed you earlier where I duplicated the plane and moved it up so we had two layers? The lower plane panned slower than the top plane because that's how perspective works. But in this case, the lower layer we made here is panning faster and not slower. So it's almost like we move this layer up instead of down. And that's actually what's happening too, and I'll explain why real quick. Remember that the incoming value is basically the angle at which we're viewing any given point on the surface. So for example, the further I pan to the right, the further the plane is from the center of the view, so it's like we're viewing the plane at a more extreme angle on the x-axis. Then this x-axis value gets added to the original texture coordinates, pushing the texture further to the right on the x-axis the more I pan to the right. Simply put, the further to the right we view the surface at, this offset is getting added to the texture coordinates, pushing the texture even further to the right, or any direction for that matter. That's good though, because it means the mechanics are actually in place. And it just means we now need to subtract the incoming values from the position instead of adding them. Adding them makes the layer look higher, but subtracting them should make the layer look lower. So let's give that a shot. Let's go over to the add node and let's switch the operation to subtract. And there we go. So now when we pan the scene left and right, you can see our texture layer is now panning more slowly than the plane itself. And that's because the incoming values are now getting subtracted from the position coordinates instead of added. And this is especially obvious around the left and right edges of the plane. When I pan around, you can see it looks like the texture layer is underneath the plane. So it has that three-dimensional depth effect that we were aiming for. And when we put the original texture layer on top of this, the effect is really going to stand out and become obvious. Right now though, let's set up a scale node to multiply the incoming values in order to increase them or decrease them before they reach the subtract node. This will let us control the strength of the effect, essentially allowing us to raise or lower the layer. So we have the incoming values coming down through this bottom line here into the bottom socket, so we'll place the vector math node over the bottom line. So let me press Shift and A, and from the converter menu, add a vector math node, and drop it on the bottom purple line there to connect it. And now let's switch the operation over to scale. And now when we play with the scale to multiply the incoming values, you can see it's like we're changing the depth of the layer. Very, very cool. I'm going to leave that set to 1 right now though, so there's no change. Now one issue is that there's a little distortion at certain angles. Like when I zoom in and I rotate, you can see there's some weird vertical distortion happening where things are getting stretched down here. Like when I zoom out a little and I rotate and I pan, things look mostly okay, but it's when I zoom in and I rotate down real close to the plane surface that things definitely get distorted. You can see this is clearly being stretched downward. And that's because of perspective. When the camera is down close to the surface like this, we're looking more straight down at the foreground that's under the camera, and we're looking more horizontally at the background that's far off. So these different incoming vectors are then getting subtracted from the texture coordinates, and because of how all the math works out, the higher foreground incoming values are subtracting a lot more than the background, so the foreground is affected more and being pulled down more. We can fix this by using the scale value though, because the scale value controls the depth. So we just need to adjust this scale value based on the angle of view to sort this out. For example, since the background appears to be higher than the foreground, then that just means the background should have a higher scale value than the foreground so that it gets pulled down more with the foreground, and then everything should even out. And since it's the vertical viewing angle, or the incoming Z value, that's messing everything up, if we divide the scale by the incoming Z value, we should get the result we're looking for. So let's set that up and then I'll explain it. So let me zoom out a little bit. We're going to add a couple of nodes over here. And let's press Shift and A for the add menu. And from the converter menu, add a separate XYZ node. With this node, you can run a vector into it, and then it separates it into the X, Y, and Z components. So we'll just run the incoming vector into it, and then we'll be able to access the Z values from that incoming vector with this output here. So let's do that now. Let's find the incoming vector. It's coming down this line here. So let me select all these, press G and move them over. And then it's coming down through this line here. So let me add a reroute by holding Shift and right click and drag through it. Then press G and move that over here. And now I'll click on this reroute and then connect it to the separate XYZ node. And like I said, we want to divide the scale value by the incoming Z value. And since the vector was separated into 3 regular values here, we're not going to need the vector math node. We just need a regular math node to do this. So let's press Shift and A. And from the converter menu, add a math node. And our scale value is currently at 1, so we'll stick with that for now. So let's put that into the top field here. And we'll drag the Z value here into the bottom field. And we'll change the operation here to divide. So now the incoming Z value is dividing our scale value here. So when we're looking more straight down at the surface, like in the foreground, that's going to be a higher incoming Z value that's dividing our scale value here. And that's going to give us a lower scale value as a result. And when we're looking more horizontally, like at the background, that'll be a lower incoming Z value that's dividing our scale value, and that's going to give us a higher scale value as a result. And that's exactly what we need to make everything even out. The foreground will be pulled down a little less, and the background will be pulled down a little more. So let's plug this in to the scale value over here now, and let's see if it works out. And there we go. You can see there's no distortion at all from any angle. It just genuinely looks like we dropped the texture layer down in 3D space. And we can play with the scale value here in the divide node to really see that effect. And that is awesome. Let's keep this scale value here set to something a little more shallow like 0.2 for now, so it's not so extreme. All right, that is looking great so far. All right, now let's mix this layer in with the top layer and see how it all looks together. To do that, we'll be combining both of these group nodes here using a Mix RGB node. So let's press Shift and A, and from the color menu, add in a Mix RGB node, and drop it over the color output of the top group node. And let's click on the color output of the bottom group and connect that to color 2 in the Mix node. And now to preview it all together, let's hold Control, Shift, and left click on the principled node to plug that back in the material output. All right, and now let's press Control and Spacebar over here to full screen this, and let's see how it looks. And there we go. So that Mix RGB node is mixing both of those layers together 50-50, and you can see how we now have 2 layers of textures, completing that depth effect, which is just awesome. And we actually achieve this with just a handful of nodes too, so this setup isn't even that complex to put together, luckily. And now if we play with the scale value here to change the depth, for example, if we set this value to 0, so there's no change in depth for the lower layer, and then we raise this up a little bit, you can see how much we can control the depth and how cool of an effect that is. For right now, let's keep the depth set to 0.1. All right, so right now, we're just mixing both of these layers together 50-50. And that's not really that great because the top layer just looks faded out. So let's make a mask to mix both layers together instead. For example, there are lighter areas of the ice, like right here, that I'd like to be more opaque, and the areas surrounding that I'd like to be more transparent. That should be more interesting than just a 50-50 mix. So to make this mask, let's use the roughness map from this group node up here, which is already black and white, and we'll just add some contrast to it using a color ramp node. So let me click on this group node and drag it over here, so we have some room to add nodes here, and I'll press Shift and A, and from the converter menu, add a color ramp. And let's drop that there, and let's run the roughness map into the color ramp, and preview this by holding Control, Shift, and left clicking on it. Now, when we plug this in as the mask for the Mix RGB node, The darker areas of the mask will show us color 1 here, which is the top texture layer, and the lighter areas of the mask will show us color 2, which is the bottom texture layer. At the moment though, those lighter areas of the ice that I want to be more opaque, like right here, are showing up as lighter on the mask right here, and the other areas are showing up darker. So this is the opposite of the mask that I want. So let's go into the color ramp menu right here and select flip color ramp. And that's going to flip these colors left to right. And now we just need to add more contrast to this. To add more contrast to this, we'll just click on the black color stop on the right here, and let's drag it all the way to the left to a position of about 0.24, looks good. And now you can see that contrast isolates these areas of the ice more, which are the lighter areas on the color map. So that's perfect. So now when using this as a mask, these darker areas will show us the top layer more, and the lighter areas will show us the bottom layer more. So it should work out perfectly and give us a convincing transparency effect. Alright, now to actually use this as the mask for the Mix RGB node, we simply connect the color output to the factor input of the Mix node. And now let's hold Control, Shift, and left click on the principled node to plug everything back in, and we'll see how it looks. And there we go. Perfect. So you can see the lighter areas of the top layer ice are definitely looking more opaque, and the areas around them appear to be more transparent because that's where the bottom layer is showing through. So this is looking awesome so far. One thing I'd like to change right now though is the color of the lower layer. I'd like to make that darker since it's deeper. So here's our lower layer here, and I'm just going to add a brightness and contrast node along this line here before it reaches the mix node. So let me press Shift and A, and from the color menu, add a brightness contrast node, and drop it on that line so it connects. And now let me zoom into it, and I'm going to increase the contrast to 0.3, and increase the brightness to 0.07. Just to make things a little darker and a more deeper blue. And that's looking pretty good. Now the next issue is that although the surface has a normal map, as you can see, this normal map does not appear to be affecting the lower layer. So the lower layer is crystal clear when there should definitely be some fake refraction of it based on the normal map. Luckily this is an easy thing to fix, and just follow my lead here at first and then I'll explain things. So let's head back to the shader editor, go over to the left here, and we're going to need to affect the incoming vector here before it goes to all these nodes down here. So let me select these and move them over a little bit. And I'll move that down to the left a little bit. And let's add a node in this line here before it branches off to these nodes down here. So let me press Shift and A. And from the converter menu, add a vector math node and drop it on this line right here. And now let's change this vector math operation to reflect. And now let's connect the normal map to the bottom vector input here. So we'll take the normal map from this group node up here. Let's make some room for it by moving these over. And I'll move this group node over. Let me zoom in a bit, and let's connect this normal output to the vector input of the reflect node. And let's zoom out and see what that did. And something weird is happening now, but you can see that the normal map is definitely affecting the lower layer, but the lower layer looks like it's been pushed up. So let's try inverting the scale value in the divide node here to push this the other direction. So let's change this to -0.1. And it looks like that pushed it back down. So I'm not sure exactly what the reflect node was doing to push that up higher, but just inverting the values fixes it, so we are good to go. And if we zoom in, you can see that the normal map is definitely affecting the lower layer now, giving us this cool fake refraction effect. So that's looking good. So this is looking much more convincing now. And now I'll explain what's going on with the reflect node. So in the Blender documentation, the reflect option in the vector math node is defined as a reflection of A around the normal B. So what does that mean? Well, A is our top input right here, which is our incoming vector, or the line that gets drawn from each point on the surface to the camera. this is what's being used to affect our lower layer's texture coordinates for this depth effect. So if we could distort the incoming vectors based on the normal map, in the end that gets added to the texture coordinates, distorting them too. So we'll end up with a bumpy effect on the lower layer that will mimic refraction. And that's where B comes into play. A is going to reflect off of B's normals, and B is our bottom input here, which in this case is our ice's normal map. And we're using the top layer's normal map because it's the surface normal map that should distort the layer underneath it. So just like a normal map will reflect light off of a flat surface in different directions, our incoming vectors will bounce off of this normal map in different directions too, creating some waviness based on that normal map. Then those altered incoming values end up getting subtracted from our texture coordinates, and in the end it results in our lower layer being affected by the normal map. And now the last piece of this puzzle will be to stretch the bottom layer vertically to finish off this depth effect and make it look like the cracks extend down from the surface. And to do this, we're going to fake a motion blur effect. Now with motion blur, you take multiple positions of something and you blur between those positions to create the illusion of motion. And that's sort of what we're going to do here. We're going to blur this bottom layer between a position of 0 and a position of -0.1. So when we blur between those two positions, it'll create a vertical blurring effect which will give the ice more depth and volume, instead of just having two separate layers. Which is really cool and probably useful for other things, but it doesn't give you a sense of volume because there's nothing in between the layers. Now to achieve this vertical blurring with nodes, we're going to use the white noise texture. So follow my lead and I'll explain as I go. So let me zoom out a little bit and we'll add the white noise texture over here. So let me press Shift and A, and from the texture menu, add a white noise texture. And now let's connect our position coordinates to this by having this selected, and then we can hold Shift and select our geometry node and press the F key to create a connection between them. And just confirm that it connects the position to our white noise here. And now let's hold Control, Shift, and left click on this to preview it, and this is what we've got so far. Now, the white noise texture basically just randomizes values. It takes every value that runs through it, and it spits out a random result between 0 and 1. And in this case, we're randomizing the position coordinates. The position of every single point on the surface is a different value. So when we run these values through the white noise texture, that's going to randomize every point on the surface. So every point on the surface here has a random value between 0 and 1 now. And this results in this very fine grayscale noise pattern you see here. You can see how every single pixel has a different value. And because every point has a different value, if we use these different values as the scale values for the texture layer, then every point will show the texture layer at a different height, because remember that the scale value moves the layer up and down. So you could have a point right here, for example, with a value of 0.5, and that's going to show the texture at that height. But the point right next to it could be a value of 0.1, showing the texture at a more shallow height, and so on. So that's the trick here, basically faking a motion blur by showing the texture at different heights on every single pixel. So it's more of a dithering effect than a blur. And if you want to learn more about this kind of blurring, I go into more detail about that in my tutorial called 5 Awesome Procedural Texturing Tricks. So now let me zoom out and go to the bottom image texture group node here. Let's hold Control, Shift, and left click on this to preview it. I want to focus on just this layer so we can see the blur effect in action. So now let's pan back over here to the white noise texture. And before we plug this in as the scale value in the divide node, remember that our divide node scale value at the top here is a negative value. And right now, all of the white noise textures are values between 0 and 1. So we need to invert them so they're negative values instead of positive. And we can fix this with a map range node. So let me press Shift and A, and from the converter menu, add a map range node and drop it here. And now let's plug the value from the white noise texture into the value of the map range node. So now with the map range node, we can convert ranges of numbers. So right now it's converting a range of 0 to 1 to a range of 0 to 1, so there's no change. But let's convert this 0 to 1 range to a range of 0 to -1. and that's going to invert the whole 0 to 1 range to a 0 to -1 range. So that's going to give us the negative values we need for the divide node here. So let's plug this result into the top value of the divide node, and let's see how it looks. So it's kind of hard to tell because it's really blurry right now. And in fact, this effect actually works a lot better in cycles, so let me switch over to that. Let's press the Z key and switch to rendered view. And there we go. You can see how this layer is getting stretched down vertically. A little bit too much though, because like I mentioned, we're getting values from 0 to -1 from the map range node, and -1 is too extreme for the scale value. So let's set this -1 to -0.1, which is what we had the divide node set to before. And there we go. So now the depth is more shallow, and we can see the effect a lot better. Cool. One thing I'd like to do though is have the bottom of the ice streaks here fade out instead of just abruptly stopping like this. And to do that, we can adjust the values using an RGB curves node, and that's what we'll do next. And we'll add that in before the map range node, not after it. We want to affect the values that the white noise texture outputs, and then the map range node will make sure all of our final values bottom out at -0.1, or whatever depth we choose. So let's click on the white noise texture and drag it over. And then I'll press Shift and A for the add menu, and from the color menu, add an RGB curves node and drop it on this line to connect it. So if you're unfamiliar with this node, it basically just reassigns values based on the curve here in the middle. And the x-axis here represents the input values, and this graph goes from 0 on the left to 1 on the right. And the y-axis here represents the output values, or what the input values get changed to, and it goes from 0 at the bottom to 1 at the top. So if, for example, you had an input value of 0.5, you can find out what its output value is by going to 0.5 on the x-axis, and then tracing that up on the y-axis until you hit the curve. And the curve is at 0.5 on the y-axis as well. So that's like saying input values of 0.5 are output as 0.5 as well, so there's no change there yet. But follow my lead here. Let's click and hold in the middle of the curve here, and that'll add a new point. Then let's drag that down and to the right, and we'll drop that about right there. And look at that. Look how the ice is more dense at shallow points and fades out as it goes down, which is exactly what I wanted. So what we're doing here by dropping this curve is basically creating more surface values that are lower. All of these values in the middle of the x-axis are mid-range values like 0.5. So by dropping the curve in the middle, we're lowering all the mid-range values. For example, that input value of 0.5 was originally right here on the y-axis at 0.5. But now we lowered that down to about, 0.2. And we dropped all of the other mid-range values down a little bit by dropping this curve too. And remember that all of these values for each point on the surface control the scale value that moves the bottom layer up or down. So if there are more points on the surface that have a more shallow scale value now, that means more points on the surface show the layer at a more shallow depth. So that's why we're seeing more density at the shallow levels and less density in the deeper levels, creating this fade out effect as we go down. So to recap what we did here, we took the 0 to 1 values from the white noise texture, and we basically changed their distribution with the curve node here, and then we adjusted their final range with the map range node, and everything worked out perfectly. Alright, and now let's see how everything looks together. So let me zoom out, and let's plug the principled node back in by holding Control, Shift, and left clicking on it. And in cycles, I don't have any lights or world set up, so it's all dark. So let's go up into the viewport shading options here, and we'll turn off scene lights and scene world so that we can use the preview world in Blender. And that is looking awesome. And if you want to now, you can play with the depth value by changing the bottom value in the map range node here. If I want to make it deeper, I'll change it to -0.25, for example. And you can see those streaks got longer. Very cool. I'm going to keep mine set to -0.1 so it stretches a little less. And now let's see how this looks in Eevee. So let me press the Z key and switch to Material Preview. And this looks cool, though the effect is definitely more blurry. That's the downside here. But there is still some illusion of depth and volume. So it's still a cool effect in Eevee. It's just not handling the blur as well. So let me switch back to cycles. And let me mute the mix node here, so it's not mixing the layers together anymore. And then we can really see this effect turn on and off, so we can see the difference. Look at that. All right, and that actually does it. This is a really, really cool effect for things like ice and a lot of other things. All right, so I hope you liked this tutorial. If you want to support my work and check out more on procedural texturing, check out my course, Master Procedural Texturing in Blender. In this course, I take you through several step-by-step projects, including creating layered subway tiles, animated lava, and painted metal. The projects are a lot of fun, and there's a ton of cool stuff to learn, so check it out in the description if you're interested. And that's going to do it for this video, so I'll see you around.